Hi there, Sam Schiffman here. Today I wanted to give you a little update on some work I've been doing around RAG on FHIR, in particular using standard deviation rather than k-nearest neighbor. So what does that mean? Well, first, what is RAG? Well, I have a number of videos out there that kind of describe what is RAG in detail, and you can go see that playlist. But just to quickly recap, retrieval augmented generation is when we take some curated data and put it into a vector store by embedding it. Then we can embed a question and retrieve information out of that vector store that is close to the question. We can combine that data with the question and send it to an LLM to get back a much more accurate and better response. I've also talked in previous videos about how HL7's FHIR standard is the perfect granularity for doing RAG. Today I'd like to talk to you a little bit about Tommy. And Tommy recently came into his pediatrician office with an elevated blood pressure. Now, when you're looking at blood pressure, it's important not just to look at the current reading. You need to think about what the previous readings are. And Tommy's data has a bunch of previous readings. All these observations here are the observations of Tommy's blood pressure. So his pediatrician wants to go to the LLM and ask for his blood pressure readings. But wait, he only got 2 responses back. There are a lot more observations that happen to be blood pressures in Tommy's data. What's going on here? Well, in most RAG implementations that I've seen, we choose to limit the amount of results that come back with what we call k-nearest neighbor. It's a fixed number of results that we're going to get back from the vector space. Now, obviously in healthcare, this can cause a big problem because we don't know what that fixed number really should be. In some cases, it could in fact be 2. In this case, it's 9. In other cases, it could be 20, right? So how do we do that? Well, I've been exploring using standard deviation. Basically, what I do is I bring back a large number of neighbors, and then I calculate the standard deviation from the mean. I then take the closest element and go 1 standard deviation from it to create a threshold and pull everything within that. And my experience is that 1 standard deviation does tend to hit the observations that are the blood pressure. So for example, now when I ask the question, I get back all the results that I expect to get back. So let's look just really quickly at some of the code behind the scenes. So this is a available in a GitHub repo. I will link in the description below. It is provided with no warranty, no guarantee that it works, but this is the code that I've been working for. First, I'm running Mistral as my LLM. I'm using Olama to run it locally. And then here we can jump into this standard deviation Neuro4j vector, which is a wrapper that I've written to wrap a vector store. And what it's doing here is it's calling the vector store and asking for the data back with the similarity scores. It then extracts the similarity scores, computes the standard deviation, and then creates a threshold, which is the first score minus the standard deviation. We can then filter by that threshold to get back the list of only those neighbors that are within that standard deviation. I have some code here to do some deduplication that is necessary in some of the use cases that I've been playing around with. So finally, I then just wrap an existing Neo4j vector in my standard deviation vector and set up the standard QA chain. So that allows me to answer questions like this one that we see here. Thank you. Please give me a like if this information was interesting to you and subscribe for future updates.